So how are math operations performed on matrices? Math operations are things like addition, subtraction, multiplication. Well, we can go ahead and take a look at a couple of examples. And you see here we're trying to add this matrix with this matrix here. The math operations that need to take place are fairly simple and make sense. You take the row column element and you add it to the corresponding row column element in the two matrices that you're trying to add or subtract by. So we take the 0 and the 6 and we add them together, and then the 1 and the 6, the 1 and the 5, and we add those together, and so on as we work our way down, and we end up with a resulting matrix with the results of those math operations on those elements. And so one thing to take note of here is when you're adding matrices, the two matrices that you're adding need to have the same number, the same dimensions, so then the same number of rows and columns, right? The same width and height. And same thing when you're subtracting. That's not the case with multiplication. Multiplication, things get a little bit weird, so it's a little bit different. If we're multiplying these two matrices, the way it works is you multiply row by column and you add up the results. So you take 4 times 0.6 plus 7 times negative 0.2, and you add the result of those two operations together. And then if we're trying to find the next element, or the row 0 column 2 element, then you take if you take the row 0 column 2 element, we're trying to find that. What you do is you take the row and you multiply it by the column there, right? So you take 4 times negative 0.7 and 7 times 0.4, and you add the result of those operations, and then you get that element. And same thing for every element in the resulting matrix, right? You take the row and you multiply by the column, adding up the answers. And so here in this kind of a situation, you could see that when you do multiplication, that the dimensions of the two matrices do not need to be equal. All right. So let's take, for example, this one here, right? The dimensions are not the same, but you would follow the same rule, right? And what is the rule? You take the row and you multiply by the column, adding up the results of those calculations. So you do 1 times 1 plus 2 times 2 plus 3 times 3 plus 4 times 4 plus 5 times 5, and you get a matrix of one element, right? It's 55. And so the same thing goes here, as you do row times column. So you do row 1, you take the one element, multiply by the one row column, and that's 1. That's the first element. And then you work your way down, and what you end up having is a resulting array that has the same number of rows as the first matrix that you're multiplying by, and the same number of columns as the second matrix that you're multiplying by. So you get something that looks like this, right? So if this has n rows and m columns on the second array or a matrix, then you end up with a matrix that has n rows and m columns. Right? So that's matrix multiplication. And what you should be thinking about in the back of your head is, what's the time complexity of this of matrix multiplication?